this computer. Okay, great. So, just to confirm, you are seeing my screen. You are logged in here into the Exploit Pack Binary Exploitation Training. So, yep, welcome. This is Juan Sacco. I guess you guys already know me. I'm the developer of Exploit Pack. And on this training, what you will learn is all about binary exploitation. I already sent you the topics. So basically what we want to achieve during this training, that is gonna take a few sessions of an hour or so. Yeah, basically you will learn all about binary exploitation, starting from stack-based overflows until rob and chop chains. Yeah, and everything in between, like memory protections, how to bypass those memory protections, how do they work, and the type of protections that you can, that you can find in the modern operating systems. And besides that, we're gonna take a look into the tools that you can use and the arsenal of tools that you need in order to develop and find exploits. So as you may know, Exploit Pack is an exploit editor that you can use to fuzz and create your own exploits. Yeah. Once you have the exploit ready into the framework, then you can use all the features that the framework provides you, like the auto-pound, like privilege escalations, browser auto-pound, and of course fuzzing. But on this particular training, we are not gonna focus on Exploit Pack, even though we're gonna use the fuzzer later, maybe in the different session, not today. So you can understand how is the process of finding these exploits. So so basically what I have here is a Kalibox. It's a Kali Linux machine with Java 8 installed. Basically it. And so there is some, it's a 32 bits. So if you are not familiar with Kali, basically it's a Linux distribution that is configured in a way that has a bunch of tools, a set of tools already pre-installed, but you can use any tool, any distribution that you prefer to, the one you like it most. But we're gonna use this one, so it will be easier for everyone. And also is this one, the one I choose is the architecture of 32 bits. So it will be stepping stones into before you go into 64. Okay, so the first thing we need is to get familiar with So where are the binaries in a Linux distribution? They are usually under user bin or bin. Yeah, and there you can, or if you wanna find new ones under under Debian type, then you can use apt and then do cache search and then look for something, tool like mp3, and then you can look for something and then install it, or use the one you have there, and then you will have some local binaries that you can start fuzzing into. Yeah, what is fuzzing? Fuzzing is making a program to work in a way that will receive random input. Then, for instance, when you are trying to do a local fuzzing for a trying to fuzz local arguments, then what you have to do is, for instance, ls, bin ls. And then if you type -help, -help, then it will have some arguments. Yeah, so you have to define the inputs because these are arguments. Yeah, but some programs doesn't have. They have different inputs. They don't have to be always arguments, as you know. There are some programs that are based on a graphical interface, and then they will receive the input in a different way than arguments. right? So, but we're gonna start with arguments because that's the easiest way for you to understand how this process works. So, so basically, by fuzzing, then you're gonna send random data. It could be totally random, or it could be some random in some parts and maybe not, or different, maybe sequence in the different parts. Because what you want to do is to go with the flow of the app, and then try to trigger something in some later stage of the application. But this is really straightforward when you're trying to fast arguments, because what you have to take is all the arguments of what they receives from the application, and then you can directly send random data into those. Yeah. There are some frameworks that they do this kind of things. Then you can set breakpoints, and then you can set, for instance, I don't know if you are familiar with a framework called Anger. That framework will follow into the flow and then of the application itself, and then it will read where or when you can trigger something and measure the output in a way that you are gonna detect if it's something that you can use or not. Something that you have to have in mind is the signals that will trigger when you create an exception. One of the most important one is on Linux is the signal 11, that is a seg fault, segmentation fault. Yeah. Okay. Enough of theory. So. If you want to follow with me, I assume you already have installed in your box. Now let me. I don't know if someone else is still on mute. 1 second, so you can also participate. Zoom. Unmute this guy. Just keep the. Please keep your microphone noise free, but I'm gonna unmute you guys so you can ask questions if you need to. I think there is also a chat. Okay, I think that's all. This must be a way to unmute everyone, but okay. Okay, let's go forward. So guys, so we need to install some tools. Let's start with, there is already one guy. There is please keep your microphone mute or noise free. So look for PEDA, GitHub, and I'm gonna show you how to do it. So because what we're gonna start is by doing by using GDB with this Python exploit development assistant. That is basically a script for GDB. That GDB is a GNU debugger. There are some different debuggers. My preferred one is IDA or Radare, but GDB is really useful for learning purposes. And also it has support of PEDA. That is, it really comes in handy. As you might know, there are some things that we can use, like here, checksec is really useful, header, XLR, readelf. We have Rod Gadget, but we're gonna use different tools like Rod Gadget, this one, and Roper. I'm gonna show you how to install it, and then we're gonna move forward into an example. Let me, 1 second. I think someone is making a lot of noise. Yeah, it was Isidore. Okay, anyway. So yeah, okay, let's install PEDA. So how to install PEDA? Well, it's hosted in GitHub. So you go there if you are here, and then go to installation. You can choose copy this. That is basically what it's gonna do, is to git clone this repository, the one we are here, and then choose drop the source into peda.py, and then it's gonna send it to GDB init. I already did it. And there are some others GDB init examples, but this one will use these Python scripts that they are really useful. So if you paste it there, then one is gonna git clone it. I already have it. That's what it says already exists, and then it's gonna echo this line, and basically what it's gonna do is to look at the source and then drop it into GDB init in your home. Yeah. So now if I go here and then I do cat.gdb init, yeah, I will have it there. Well, I did it 2 times. Doesn't matter. Well, actually, I can remove one. Yeah, and under peta, in my home folder of my user that is here, yeah, then I will have the Python script. Yeah. Okay. So now, if you run GDB, you will have to see that your prompt is on red. Okay. And now, if you do beta help, you will find that besides having the help of GDB, help like this, yeah, if you do beta help, you will have additional commands, commands that you can use under GDB, like checksec, yeah, or to check for the security options that that binary could have, proc info, readelf, and yeah, all of this. Yeah, and there are something really useful. There is this pattern, create a pattern search. So basically, this is this kind of script, Python script for GDB is pretty similar to Mona. Yeah, that Mona is I think it's also Python. And it is basically for Windows, and you can use it on WinDBG and OliDBG or Immunity Debugger. Yep. And that's for Windows. Well, we are doing it on Linux now. As far as I remember, there is no Mona for Mona is from Cortland. There is no Mona for Linux yet. Okay, so under your Kalibox, I don't know, I think it comes by default. So we're gonna use one of the exploits that I created, exploit db, Jan, I think it's this one. Let's go here. Yeah, so perfect. We have 2 different kinds of for this one. So we're gonna, as you can see, we have 2. One is with a rob chain, and the other one is without it. Okay, so first we're gonna go without the rob chain. Yeah, this one that is without the rob chain. I'm gonna explain you how it works, and we're gonna do it under GDB. Yeah, with the rob chain, we can also look into it, and then we can create the rob chain manually, or we can use one of those tools like Roper or RobGadget to create this rob chain. Yeah, but you need to understand why do we use the rob chain, yeah, and how does it work, and what is a rob chain. And after we have the knowledge of how a rob chain works, then we can move forward into job, that is jump-oriented programming, and rob is return-oriented programming. Okay. So as you can see here, this is a Python script that is for Java Decompiler that you have installed is under the path. The full path is user being Java, as far as I remember. Yeah, it is. So it's a Java Decompiler, yeah, that you can use to actually decompile jar files. Yeah. And that's the purpose of this program. So if you do man jar, well, there is no documentation about it, but there is a website and you can read more about chat. There are some programs that also use chat, as there are some graphical interfaces for Java Decompiler for doing that. In the behind the scenes, they use actually this binary chat. Also for Windows and OS X. Okay, so that's the purpose of that. Yeah. So what we want to do is to, yeah, we can first do it here, bean JAD, and then what we can do is to run it into Python, as let's print. This is like this, and what I'm doing here is instead of just running JAD, I'm sending to the first argument of JAD 9,000 A's. Yeah, so if I click enter, then it's gonna try to do something with that argument. That is Java file with exception. So basically, what it's trying to do is to find use it as a file name or as an option. And then it's going to send all those A's. And as you can see, after the output of the program, that this is the output of the program, then you will have a segmentation fault. Yeah? And if we set, if we do this, yeah, you will see that that it changed it. Instead of just saying segmentation fault, it says core dumped. What I did is set the U limit to unlimited. So basically, that what will allow us is to create these core files. Yeah, and then with GDB, what I can do is to look for the core file like this, minus minus core equal the core file. So minus minus core equal, and it's called core, but it could be called anywhere, anything. So as it says here, it's a program terminated with a 6 segmentation fault signal. There is 11, and then it tried to go into 41, 41, 41, 41, 41. That is basically the hexadecimal value of A, capital letter A, otherwise in lowercase will be 61. And then, yeah, that's it. And if we do backtrace, then we can see where it tried to, we can do where, that is basically the same, and it tried to go where, yeah. So let's keep this, and then what we can do is to do it inside GDB, user being JAD. So I think if you guys have any questions, just you can interrupt me, or I think you can drop me a message using the platform. Okay, PETA help. Yeah. So we already triggered the segmentation fault. What we want to do is to define how many A's do we need to for that offset. Yeah. And then this will go later, the knobs and the shellcode that we can use, and the stack and the value for ESP. And then we are creating a buffer. Yeah, here the buffer is chunk plus, that is this A's in capital letter, plus the ESP value. Yeah, plus the knobs, plus the shellcode. Yeah. And then we are running all this inside a try catch by looking into exceptions if it writes any as an error. And then if there is one, then we're gonna drop a message saying chat is not found, or else every error executing exploit. Yeah. So what is important here is that you understand this part. So you already know that the 41 value in hexadecimal corresponds to capital letter A, but you don't know why do we use 8150 A's. Yeah, I'm going to show you why do we use that. But inside PETA we can use checksec. Yeah, and if you do checksec, then we can look into the protections that this binary has. Yeah. At this moment, we can see that there is no canary enabled for it. There is no fortify. The NX bit is enabled, and we have no P or railroad. Yeah. So this binary is pretty straightforward. So yeah, let's do it here inside again, inside PETA or GDB. Sorry. with beta. If you want to run it, you can have to do run then, or run -- help. Yeah, and then yeah, -- help. So run will run the program, the binary that is running inside the debugger, and then if you do -- help, you are actually sending something into the binary, an argument to the binary. You can do, for instance, let's do something real like b. Is there a way of looking at the version? Well, you got it right. So run, and then it's like doing this bash shows inside the debugger. Okay, so what we need to do, yeah, we can do run, and then we can do the same by 9,000 A's. Yeah, and we can see by running this, yeah, run Python -c, that is command, and then print A's by 9,000. Yeah, and we have here the registers. So it says after running it, you can see here. So we run this, and then started the execution of the program, starting program with this argument, and then it says Java class file read exception cannot open input file on 9,000 A's, and then it overflowed the stack. Yeah, and by overflowing the stack, it triggers a direct read, and by using that, by abusing of that, we have control of the instruction pointer. Yeah, there is this one, and it has a E in front because it's extended instruction pointer in 16 bits. It will be IP, in 32 is EIP. Yeah. So then we have registers, that is EIX, EBX, ECS, EDX, SE, AD, EBP, the back pointer, and the stack pointer. Yeah. And as you can see, we don't have only control of the instruction pointer, but also of the back pointer. We have something inside. Yeah, as you can see, it's colored in a dark blue. And then we can see that inside this memory address, we have also A's, but we don't have control of the memory address, but we have control of what is inside there, the pointer. Then EBX, we have full control of it. So we have 41, 41, 41 there. And then here we have the stack is divided into code. The code is pointing to 41, 41, 41. That is a PC's program control or instruction pointer. So basically it's pointing to a code segment that is not valid at all. There is nothing there in 41. And the stack pointer is full of, inside the stack, is full of A's. So we can do this, for instance, is for, let's do 100 ESP. And there we can see that our stack is, yeah, full of A's. So how this works, when we are running this, what we are doing is overriding the instruction pointer, and we are overriding the value of the value that the instruction pointer is going to take after doing a read, and then moving the value into the instruction pointer, and that's how an overflow works. If you don't get what I'm saying, then what I will recommend you is to look into a smashing stack from the Prac magazine, and then you can look deeply into it. But this is pretty basic and really straightforward. This is the most basic what you can do. Just a second, guys. Yeah, sorry for that. I got a call. So, okay. So what we need to know now is how many A's do we need in order to take control and modify the values of this. So because now what we're doing is modifying the values of instruction pointer with A's, but what we want to do is to put something real, something that we can go into. So how many A's do we need before we overwrite the value of that is gonna be taken to the red to AIP? Yeah. So beta, as I said before, has this pattern arc, create environment, offset, patch, and search that we can use. So what it's gonna do is gonna create a D-Brown sequence. Yeah, D-Brown sequence. You can also create it using exploit pack and then use a search, or you can do it directly into Peta. So how to do it is pattern create, and then we can say, okay, 9,000, and then it's gonna drop us the Brown sequence of 9 or of a value of 9,000. Yeah, and this sequence is gonna be sent into the stack if we use it as an argument, and we can do it in two ways, like this: run Python-C print, and then we can get this and drop it here. Yeah, and then we, as you can see, I sent all this sequence like that. And then we can do pattern search to look into that sequence. Beta is gonna look into it and then let me know, yeah, about the offsets that I need to use. And as you can look into this one, if I want to take control of the instruction pointer, then I need to use 8,150 chunk, yeah, A's or B or the Brown sequence or whatever I want, in order to take control of it. And if I want to control the back pointer or EBX or ECX, then I can do that by using this offset. Yeah. And then the pattern was also found into the heap, yeah, like so. And there are some reference found there. So there is also another way. There is pattern argument 9,000. Yeah, and now it should add 9,000 of the 9,000 values of the Brown sequence into my first argument, and then if I do run, is sort of the same, but this is more clean. It's more cleaner than doing this. Yeah. Okay. So but it's the same. Now if I do pattern search, I will find that I need to use 8150. Yeah. So now what I can do is print A by 8150 plus ABCD, like that, or I can choose to dev beef. Yeah, and as you can see, or I can do ABCD as before, so I can show you the difference. As you can see, I have control of the instruction pointer, and I sent ABCD there, but as I said before, the value of A is on the back, and I sent it on the beginning. That's because this architecture is a little Indian. So if I want to actually send one, if I want to see what I sent in a proper way, then because little Indian, then I have to send it in reverse. So if I want to see here 41, 42, 43, 44, then I have to send it in reverse, like so. You see? And you can see that the back pointer and the EBX is still using the amount of A's because the offsets of those were lower, yeah, than 8150. Now, if we go back to the exploit, we can see that it matches what we have here. Okay, and then we have the NOPs. And NOPs is a non-instruction, so basically it's a dump cycle of the CPU. That what it's gonna do is to choose go into this NOP. That is, and it's called NOP-SLED, because what we can do is to modify the value of ESP, yeah, or EIP, call it wherever you want it, and then go into there, and then instead of going directly into the shellcode, we can jump into the NOP-SLED, and then it will execute those NOPs and then run the shellcode. Yeah, that the shellcode basically, as you can see here, is a BNSH, and then it's using CD80. Yeah, so it's using the interruption 80 in order to run this as a exec, basically. Yeah, so it will run BNSH and it will get us a shell. So let me, in order to make this work, I think we need to copy it. Let's check it out. So like that, and then let's create exploit.py, or we can do nano exploit.py as with the editor. I prefer B, but so I can show you like that. And if you use Beam, you will also have highlighting. Yeah. So if we run this, as you can see, the exploit itself called JAD and send as an argument this one. Yeah, this is the argument. But what we can do, and yeah, and of course it executed this robocall of the ESP that is part of JAD, and this is gonna go into ESP basically, and then it's gonna execute the NOPs and the shellcode itself. If we wanted to stop this execution, what we can do, let me exit. We can use CC, that is an interruption. Yeah, instead of using ESP. So if you wanna see what is happening. So let's open JAD and let's do it manually. Run Python -c print A by 8150 plus the NOP-SLEDs by 24. Now we say sorry, it's chunk plus ESP. So here is where we're gonna use the CC, so we can interrupt it there. Choose one CC is enough, but just to keep it aligned. NOPs by 24, and then the shellcode itself plus the shellcode. That, as I show you, it does work. So when I run this, what is going to happen is going to overwrite the stack. It's going to put this value, yeah, as the reference for EIP. It's going to move after the thread is going to move this value into EIP, and then when it tries to execute this, the debugger is going to stop the execution because of the CC. Yeah, so if we do that, as you can see, it's getting the CC, and I did it because I wanted to show you, it's like setting a breakpoint, basically. Yeah, so so I can show you the value of the stack pointer. Yeah, and as you can see, inside the stack, I have all my knobs here. 24 perfectly aligned. That is why I'm using 24. And then I have my shell code. And as I mentioned before, my shell code goes like this. Yeah, it's like so. Here's the first four. Yeah, 31, C0, 50, 68. Yeah, and then this is the slash slash. Yeah, here, slash slash. And then the hexadecimal value of SH here, SH. Then 68 here, 68. And then pin 89. Yes, here. And then E350, E350, until here. Yeah, until here. So this is the shell code that we are sending into the stack. This is the code that we want to execute into it. Yeah, this is not using RobChain. This is the most basic stack-based buffer overflow you can do. Let me take a sip of water. So this is the most basic you can do. Okay, but it does work, and you can say, hey, but how the hell did you got this? Yeah, because what you are sending, this is a value that is doing a champ ESP, yeah, well, call ESP in this case actually, but because when I overflow in the stack, yeah, with my modified value, what I want to do is to go back into the stack, because that's what I'm controlling, yeah, and as I show you, my shell code is in the stack. So, and the stack is pointing here, yeah? So what I want to do is to jump into the stack here, yeah? So if I can jump here, then this will get executed, yeah? All these knobs, and then all this line, and then all this line again, and then after these knobs, yeah, no execution, will execute my shell code. So it's gonna do this part, and then the shell code. Yep. So in order to do that, what I can do is to use a hard code value. I can send this into the stack. Yeah. And if I want to hard code it, then if I want to send this, it will work, but only on my machine. Yeah. So I have to do it like that. I'm typing in reverse because it is Little Indian. Yeah. So BF, FF, CA, E0. Yeah. If I do this, it will work now inside the debugger, but if I send this exploit to you, if I send this exploit, if I use this as an exploit and I send it to you, you will have different values for the stack, yeah, because these values change, because these are part of the memory and it will change, yeah. So that's why we use this rob call ESP, yeah. That is basically a value that we can get, yeah. As you can see, it does work, yeah, using the hard-coded value. I'm sending the hard-coded value of where my shellcode is, on that particular time. But if I send, as I say, if I send this to you, it will not work in your computer. So how do I get, so I got a shell. So let's type exit. So how can I get these values? And what are those? So that's, as I said, is a call ESP or sham ESP. And what I can use in the most basic way is to use object dump and then -d to decompile. Not inside GTB, sorry. Object dump -d to decompile, user being JAD, and then we can look into all this decompile code and then look for values that will represent a call ESP or sham ESP. Well, to be honest, there is easiest way to do it, and inside beta we can use rob search or searchman if you want to do it through a regex, or rob gadget. For instance, let's do rob gadget. Like that. Beta help, or we can use robber outside this one. So I think there is a jump ESP. Where is it? This one, sham call. Why it says sham small? Share for kernel instruction in memory. I think we need to run it. Let's use the CCs. Sham call. Yeah, there you go. Or what we can, and there are more, and then you have to choose. So basically, all these values, yeah. What you have to look for jump ESP or call ESP, because you want to go into you don't want to go into EAX. You want to go into the stack pointer. Yeah, and that's how you can get there. Rob gadget. There is a program that you can use as well, or robber. Rob gadget. And here you can look for useful gadgets. Might take some time, but we can do it. Binary user being JAD, maybe not. Yep, just wait for it. And then it's gonna show us all the useful gadgets. Yeah, and here you can search for a jump or call ESP. Well, I think we can do it again and drop it into a file. Log chat.log. Just 1 second. There's one, it might be the same one I use. Yes, actually it's exactly the same one as I use. So this is a call ESP, it's not a jump ESP, but jump ESP of course will work just fine, it's doing the same basically. So, and as I told you before, when I use it inside the exploit, I use Little Indian, so it's 08, 0E, 2E, 80. And what you have to be aware of is that most of these kind of stack-based buzzer overflow, that they are triggered using arguments. It cannot contain double zeros, because double zero is the end of a string. Yeah. So if you have an address that has a double zero in it, it will cut the string before it goes into the stack. Yeah. So this does work. Yeah. but it's not using a rope chain. So how can we create this rope chain? We can use rope gadget as well. Later on, not on this session, but we're gonna create a rope chain manually, so you can actually understand how a rope chain works. Not only create the rope chain using a program, but you have to understand how it works. So that's I have some binaries that we can use on other sessions, so you can actually understand how a rope chain works, how execb works, how because if you don't understand that, then you will not be able to get champ-oriented programming. So if you want to create the rope chain automatically using rope gadget, is minus binary, and then user being Jack. And wait, I'm gonna show you first. Roper instead of yeah. So roper is a same type of tool. So minus file minus binary user being that, and you can do this on exploit pack. If you open exploit pack and load the binary on the rope chain, and it will create the rope chain for you, and then drop it directly into the exploit editor. So you can do it in a terminal or under exploit pack, just browse for the binary, and it will try to get the rope chain, and it's gonna use execb as a function. Yeah. So let's try to create a chain, and we're gonna do, yeah, as I say, execb, and we can run this command to do the same as the shellcode. And yeah, I think that's it. I just have to wait because it's looking into it, and then it created this rope chain for us. Yeah, based on execb. Yeah, so it's gonna print the rope, and then directly we will have it directly here. So let's do the same using rope gadget. As I say, it's a minus binary. User being jad minus. I think it's chain. Let's confirm that. No, rope chain. Yeah, rope chain. Yeah. It's gonna take a while, and then it's gonna create it for us. Sometimes this doesn't work, and you have to do it manually. So, but it tells us how it created the rope chain, and then yeah, and then we have it here. Basically, the exploit. So if you do rope chain.py, so let's put it like this, like that. Oh, yeah, we have a problem here. Let's create a macro. And just repeat the macro. Like that. Save it, and what we need only here is to add the chunk. It's 80 ace by 8150, and then it's gonna send this as our rope chain. Yeah, and then at the end it's gonna do the interruption, and we will get the bean sh through execb. Yeah, you can create this exactly ROP chain manually, or you can use Roper or ROP gadget if it's possible for those programs to do it for you. So what if we want to run it, then we need to do GDB Python we say robchain.py. Oh yeah, because we didn't, it's an error here because we forgot to import struct into it, so Python doesn't know how to handle it. Let's go to the top of the file and then just import those. Let's confirm that at the end. No, it's not printing it. Yeah, so we need to print it. Print p Python robchain, and it's printing it. So yeah, just modifying the exploit so I can run it inside GDB. It's being chat run Python robchain.py, and there you go. We got the shell using robchain. So yeah, and I stopped the execution because we are inside Python, but we can also do it from here. User being because we have inside GDB. So Python robchain.py, like so, and then we have our shell. Okay, guys, I think that's more than enough for this first session. If you have questions about this training, just drop me an email.
I just have a small question, if I can.
Yeah, for sure.
We saw that when you run checksec, we saw that the NX byte was activated, I mean protection. So I'm wondering why is in this case the local stack-based buffer overflow without the ROP is working? Because we are executing on the stack, right? Or
yes, exactly. But it will not work if you do it outside GDB.
Ah, yeah, okay. Because with the ROP it should work, right? Even
yes, and yeah, and even on the on this example, we are using a ROP call.
Yeah.
So anyone else has a question, guys?
Yeah, I just have a quick other question about is the fact that you're using a ROP gadget for the call ESP is also bypassing the ASLR randomization?
No, it's not.
Okay.
Well, it is using it is part of the binary, and the binary is not randomized, but that's not the way. That's not the way of bypassing ASLR. So I don't want to confuse you.
Okay, thanks.
But yeah, I think on the next session we're gonna look into memory protections. So yeah, yeah,
great.
so we can understand how those works. Okay, guys. So if there is no more questions, so I'm gonna end this session. Yeah. So let me know if this time is good for everyone, or if we have to change it. So basically, what I'm trying to do is to pick up a GMT that is sort of between everyone. So there is no one taking this training at 4 in the night. So that's. I hope it was a good time. We can also move it into weekends or just keep it on during the week. And in the meantime, if you have questions, drop me an email or contact me directly through a ticket or yeah. So if you have questions, or also you can look into this record, yeah, on your computer if you wanna
Yeah,
follow the video.
about the record, will where it will be available so that we can look it back.
Yeah, I think I'm gonna send it up today by email.
Okay,
So yeah, so I don't know how that worked because this is the first time I'm using this platform, Zoom.us. So yeah, I have to look into how can I get the video. But I did press record, so I hope it works. And then yeah, I'm gonna send it to you guys.
okay, thanks.
Okay, thank you guys. Yeah, let's keep in touch. Bye.
Bye.